In all of these problems, x has been approaching a number, and the limit has been negative or positive infinity. In the next set of problems, we're going to look at x is approaching infinity and see what happens when that occurs. So label these limits as x approaches infinity. And basically what happens, so if we think about our little xy axes, we kind of have a couple of options. One is that the curve could sort of go off up to positive infinity. Another is that the curve could go down to negative infinity, or it could sort of flatten out into a horizontal asymptote. These are sort of the three options that we have. The limit could be positive or negative infinity, or it could be some particular finite number. So the problem with this is that infinity isn't really a number. We can't really plug it in the way that we've previously done with numbers. However, we can plug in larger and larger numbers for x to find the limit as x approaches infinity. Basically, what would it want to be if it was possible to plug in infinity? That's going to give us a couple of rules. Let's first write So to do that, we need sort of some infinity rules. First, a very large number times any other number is still a very large number. Large, I mean in magnitude, so it could be either very, very positive or very, very negative. And in fact, the rules for multiplying positives, and negatives hold regardless of how big the numbers are. Which is kind of cool when you think about it, because like 1 plus a super huge number, like we don't care about the 1. It's just too small to even pay attention to. But -1 times a very, very large number shifts the sign. This little tiny -1 can do this massive change even to this really huge number, which I think is pretty cool. One other rule is the one we were working with earlier. A number divided by a very small number approaches positive infinity or negative infinity depending on the signs of the number. And then our final one is the really critical piece for the rest of this. A number divided by a very large number approaches 0 regardless of the signs of the numbers. So where this one's going is that if I take, let's say, 1 divided by 10, and I start getting bigger and bigger and bigger, that's just moved the decimal point 4 places to the left, so that's close to 0. That's even closer to 0, and so on and so forth. The bigger the number is in the denominator, the smaller the number is overall. This is true even if I have 1 divided by, let's say, negative 100. It's still a negative number, but there are so many zeros, we almost don't care if it's negative. It's just so close to 0. So this is the key one for what we're about to do next. Oh, there is one other key piece. When we are working with very large numbers, approaching infinity, the terms in the numerator and denominator that have the largest exponent overwhelm all other terms. Basically, let's imagine we had a number like, 100 million or something like that. 100 million to the 5th power is such an enormously huge number that it completely overwhelms even 100 million to the 4th power. Because 100 million to the 4th power is really, 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 really huge, but 100 million to the 5th is 100 million times bigger. And it's so much bigger that we can essentially ignore even a number like 100 million to the 4th. Even though that's huge, it pales in comparison. It's kind of like saying, an elephant is really, really big, but when you compare an elephant to the size of like the entire planet, the elephant's so small you can basically ignore it. So let's look at some examples. Let's find the limit as x approaches infinity of 3x squared plus 5x over 15x plus 2. And what we were just talking about right here is saying that when we look at this 3x plus square plus 5x, if we're dealing with numbers like 100 million, a quadrillion, a billion, 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 close and closer and closer to infinity, this square term is so huge that this one we can basically ignore. The same thing here. This term gets so huge that we can basically ignore this too. So this behaves like, I'm just going to circle those big exponents. Behaves like that. Now notice I am not saying it equals. Because it doesn't equal. I'm saying because x is approaching such a large number, we can kind of ignore these for practical purposes. The effects of these other terms get so overwhelmed. But it is really important. This behaves like, it's not that these two are equal, because we just like took these out. We aren't allowed to just like take out random things, except that for practical purposes, these two parts are overwhelmed and we can ignore them. Once we have this, we just simplify it. Once I've gotten past this part, this is equal to what I'm about to do. So the x's cancel out, 3's cancel out, so we have x over 5. And the thing is, this is 1/5 times x. As x gets to be a really, 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 really big number, even if we're multiplying by 1/5, it's still a really, really, really big number. So as x approaches infinity, it gets bigger and bigger and bigger. X divided by 5 continues to get bigger and bigger and bigger. It approaches infinity. So for this one, we find the biggest exponents in the numerator and denominator, so they overwhelm everything else. So this behaves like the limit as x approaches infinity of 3x over 5x squared. So those x's would cancel out, so that would be the limit as x approaches infinity of 3 over 5x. Now, look back at what we were saying here. A number divided by a very, very large number approaches 0. So as this gets bigger and bigger, 3 minus 500, 3 minus 500,000, 3 minus 500 million, zillion, quadrillion, billion, this is getting to be a finite number divided by an incredibly huge number. And when we divide by a very large number, that limit, that's approaching 0. Very, very key. People like to forget this one a lot. What can also happen is we can have situations like this. They're our biggest exponent. So this behaves like notice how in this case, whoops, there's the example. Notice how in this case, x to the 5th and x to the 5th cancel out. Because no matter how big they are, they're always equal. And anything divided by itself is 1. It just always is, even if it's 10 million, quadrillion, billion. Now, when we go to put our large number in and see what happens, there is no x anymore. So, since we can't put this in, all that we have is 4/3. The limit is just 4/3. And what this is really saying is it's really saying that when we would draw the graph, there is a horizontal asymptote at y equals 4/3. This one actually is also a horizontal asymptote. Y equals 0. All that's saying is it's saying that as we draw our graph, there we go, that's the second one right here. As x gets bigger and bigger and bigger, y is getting closer and closer and closer to 0. It's just leveling out at that horizontal asymptote. We can also end up with limits where the sign changes. So the limit as x approaches infinity of negative 3x to the 5th plus 7x to the 4th over 2x cubed plus 9. So the biggest exponents here behaves like bunch of canceling out is going to happen. Negative 3/2, that's x squared. So what's happening is that this x squared, as we approach infinity, it's a bigger number, so we're getting one of the infinities, but because there's a negative, it's going to be a positive times a negative, or a negative infinity. We can also work with problems where we are taking a limit as x approaches negative infinity. Same idea, it's just we might have a different sign. So let's say our function is 4x to the 4th plus 7x squared minus 2 all over 6x plus 1. That means these are our terms to the biggest exponents. Oops, this up here should have been the limit as x approaches infinity for that one. So that would be the limit as x approaches infinity of 2/3 x to the 3rd. This is negative infinity, my bad. So as we put negative infinity in, a negative cubed is still going to be a negative, times a positive is still a negative. But this infinity cubed is going to be huge, bigger and bigger and bigger and bigger and bigger and bigger numbers. So it's going to be approaching negative infinity. Let's do a couple more just for practice. It's going to approach negative infinity. These are the terms of the biggest exponents. Those x to the 3rds cancel out. There's no x to plug any numbers in for, so just 7/3. Again, that's going to be that horizontal asymptote. And for our final example, let's do another one with a asymptote. Largest exponents behaves like we're going to be dividing by a very large negative number. It's going to be squared, so it'll eventually be positive. But anyway, a very large number up here, down here. Regardless of the sign, a number divided by a very large number approaches 0 as that number gets larger. This is one, again, very easy to forget.